Hello, my name is Alex Reitman.
Dustin Stevenson.
Jake Feller.
Candace Pop.
My name is Ryan Fletcher, and we are the Purdue Quarter Scale Tractor Pull Team. We compete in a legacy competition every year through the American Society of Biological and Agricultural Engineers. So we're subject to some of the design constraints of the competition, such as weight, length, width, engine, tire size, and other things like that. So this year our project goals were to increase the reliability of our drivetrain, to provide real-time feedback to the operator, to increase operator safety and the serviceability of the tractor, and also to tune our CVT with a new dynamometer for better performance.
When designing the tractor this year, we tried to meet the demands of 3 different customer market groups. The first of those being competitive tractor pullers. These people require a high-performance product that is serviceable and safe. And then the other 2 groups we grouped together being hobby farmers and landscapers. So hobby farmers work approximately 5 acres of land, and both the hobby farmers and landscapers need a tractor that can handle variable field conditions, use implements, and have an ergonomic operator's area.
This year within the drivetrain design, we tried to increase the reliability. By doing this, we integrated the transmission, transfer case, final drive, and a locking differential all within one housing. We also continued using the continuously variable transmission. We utilize a Kubota front axle, and this year we will be featuring 3 forward speeds with ratios from 1:1 to 3:1. This drivetrain setup has a 27% weight reduction in comparison to the 2015 model.
When designing the operator station, the overall objective was to have an improved operator experience. So this was accomplished by having adjustment that can accommodate up to a 95th percentile operator in both the seat and the steering adjustment, eliminating pinch points that were prevalent in the 2015 model, as shown here, and then paying attention to the operator zone of comfort for dimensions.
This year, something new we added to the tractor was a data acquisition system. Our objective here was to provide real-time feedback and tractor performance. Included in this year's package is engine RPM, the shaft RPM after our variable transmission, and ground speed of the tractor. This should give us a competitive advantage at the competition, and we also have a phone application in development.
As Ryan mentioned in the opening statement, one of our goals this year was to tune our CVT. Tuning the CVT allows for better performance during competition pulls, and the overall design of the CVT dynamometer would help us test various setups quickly. We looked at some alternative designs of using a 2-stage pump and various layouts to make sure we had a fully effective dynamometer.
To increase serviceability of the 2016 tractor, we've utilized a lot of areas that are easily visible. Our service manual explains each way that the tractor will need service throughout its life. We also have increased manufacturability by using a lot of common materials. We use a CNC plasma cutter, press brake, and the tractor is now powder coated, and the tractor can now be produced in a full assembly line with sub-assembly branches.
On to impact and sustainability of our tractor. Some new designs were chosen to reduce the material used and wasted. Such things were simplified frame, our wheelie bars, and our hitch mount. Fluid drainage tubes were installed to ensure all the oil mixed into the drainage bucket when servicing the vehicle. And we also added lightweight 4-wheel drive design to reduce soil compaction and yard damage.
Finally, another part of the competition is an economic analysis. As seen here, we were able to reduce the overall drivetrain and cost of the tractor by 3.5%. We were focused on reducing the engine, transmission, and drivetrain costs because those account for 53% of our total expenses.